What IGNOU is doing specific. May I request request Dr. Imran to share the need, importance, and its analytical component on the subject. Dr. Imran, please.
Thank you, Dr. Sloja. Good afternoon, friends. This time I will speak about the residual pesticides in food chain and its analysis part. So let me introduce pesticides from the very basics. The increased agriculture production necessitates the use of a large number of synthetic chemicals and fertilizers. Many of these inputs are beneficial only when used specifically and applied judiciously. Because if you are not using it specifically or applying judiciously, you may not be getting a good results, and you will end up a more residual load onto the ecosystems. Say for example, different pesticides are available in markets. Farmers are generally using these pesticides, and most of the times they may not be aware of which pesticides needed to be used in a particular crop, in a particular atmosphere, or in a particular geographical area of the country. So specific and judicious is very important. Unfortunately, this is not happening, and we were not aware of this judicious use from the beginning. So therefore, we were using any number of pesticides, any type of pesticides in any kind of environment. We were using even organochlorine pesticides group like DDT, BHC, which was later on found that very dangerous to the ecosystem, to the human population, to the animal population, to any other kind of ecosystem. So gradually we recognize that this is the problem we need to rectify, and we started banning these dangerous pesticide groups one by one. So as I said, many of these inputs are beneficial only when used specifically and applied judiciously. Means you need to find out which pesticide is needed to be applied on a particular crop, in a particular season, in a particular area of the country, and its use of quantity of use of these pesticides is also important. You should not use the more quantity of pesticides in a particular crop. Many of these have become contaminants of the environment, either due to improper excessive application or due to their persistence in the ecosystem in soil or plants. As I said, if you are not using this effectively or judiciously, it becomes the contaminants of the environment, or either due to improper excessive application, or some of these pesticides can persist in the ecosystem for 100 years, like DDT. Some of them can persist in the ecosystem for about 15 years, 50 years, 20 years. So these contaminants remains in the environment for a longer period of time, and they create a threats to the human population and any other kind of population in the ecosystem. So we need to justify our use of pesticides. In recent years, the status of chemical pesticides has undergone a sea change from being one of the major instruments of success of green revolution to an agent polluting air, water, soil, and entering to the food chain. While it was instrumental while we were working on a green revolution, we used these pesticides to remove the pathogens and insects in our crops. But at the same time, we were not aware of its dangerous scenario in the future. So that time we end up with a large volume of application of these pesticides. Most of them were later on went for use in Indian agriculture. These things should be taken care while you are selecting and using a particular type of pesticides. We need to educate our people who is actually using these pesticides. Say for example farmers. If we are not going for judicious use of these pesticides, then situation is bound to deteriorate for each year ahead, as the farmers are becoming increasingly injudicious about the application of pesticides with the idea to exterminate insect pests totally. Means most of these farmers are not aware of its judicious use. They are generally having an idea to use as more pesticide as possible to deteriorate the pest or insects totally. They are not aware of the threshold level of the requirement. There is a threshold level of a requirement of all pathogens and pesticides. The threshold means we should use a pesticide so that the pesticide or any other agrochemical, so that the population of insects or the pathogens should decrease to a threshold level, so that it should not damage the crop or any economy to a level where the situation is going to be very bad. Now, what is pesticides? Pesticides can be any substance intended for preventing, destroying, attracting, repelling, or controlling any pest. It may be plants or animals. So this pesticide can be any chemicals or drugs. It can be any form of growth regulators. If it is given in a excess dose, it can create a problem to the ecosystem. So in that perspective, we need to check the judicious use of these pesticides. So far as classification of pesticide is concerned, it can be classified in terms of insecticides such as inorganics like arsenate, organics like organochlorine pesticides. There is a group of organochlorine pesticides like DDT. There are 6 isomers of DDT, and there are 4 isomers of BHC. Linden is one of them. So very effective. It initially, now it was thought that it is creating more problem than helping the farmers or producers. There are carbamate groups of pesticides which is used in Indian agriculture. Natural products, it can be a botanical like pyrethrum, means pyrethroids, and microbial like ivermectins. So apart from inorganic and organic, there are some natural product of group of pesticides also available in the market that can be used to minimize the pest or insect population below the threshold level. There are herbicides. It can be inorganic like chlorates, organic like diuran. There are some other acid herbicides available in the market like 2,4-D, isoproteron that are in use in the Indian agriculture. There are fungicides like inorganic, for example copper sulfate, organic for example captan. There are rodenticides, for example inorganic barium carbonate, organic warfarin. There are some fumigants like methyl bromide, which is used to fumigate the storage grains and other produce. There are some apart from this, there are some natural toxins that is also in use in some part of the country. There are growth promoters. People are using to promote the growth of a particular crop faster to avoid the insect and pest population in a particular season. So they want to harvest the crop before that insect and pest season starts. If those are inaccurate or given in more quantity, so it can create a problem to the ecosystem. Now, what is residue? Residue can be a drug or chemical or its metabolites. Whatever drugs or chemicals are applied on a particular crop, it remains on the crops surface of the crops, most of the times on the residues of the crops. Grains are less contaminated as compared to the residues of the crop. And what is happening then in Indian scenario, those residues are given to the animals in the form of feed. So these pesticide goes to the animal feed. There it gets metabolites and converted into a metabolite form of particular pesticides or drugs. It comes out in the animal products, maybe in meat or milk or any other kind of other animal product. These drugs or chemicals or its metabolites may accumulate and be deposited or stored within the cells, tissues or organs of an animal. Following the use of drugs and chemicals in control and treatment of animal disease, or a feed additive used to promote growth and feed efficiency. As I discussed, if feed additives are used to promote the growth or to promote the feed efficiency, if it is not given in a proper calculation, it can give a wrong result and can be part of a contaminant. Now come to the role of the pesticides. Pesticide used to control the pests, diseases or of livestock or plants. It controls of insects in environments. It controls the insects in barns and stables. So initially the pesticides were incorporated into the Indian agriculture to control the pests and diseases of livestock and plants. And it was, as I said initially, it was a instrumental in the Green Revolution in India. The major part of Green Revolution was a dwarf gene imported from Mexico. It was the dwarf gene of wheat variety. Then the other parts of the Green Revolution was the use of fertilizers. By that time, most of the Indian farmers were not aware of the using the synthetic fertilizers. At the same time, we were not aware of the using of pesticides. The planning of Green Revolution was that to increase the food production at any cost. Because of this thinking, we forgot the hazard point of the using of these pesticides, and we ended up of using those pesticide which is actually banned in outside country, most of the time in US and European Union. But later on we found that these some of these pesticides are not useful in terms of they are giving more bad effect than the more good effect. So we started thinking on those lines. We stopped most of the organochlorine pesticide groups of pesticides in India. Still there are some group of pesticides like organophosphorus, organosulfur. Some of acid herbicides are allowed to be used in Indian agriculture. In general, there are more than 30 pesticides which is allowed in Indian agriculture in terms of maximum use of group of pesticide is concerned. And in total there are more than 100 pesticides generally farmers are using in Indian agriculture. These numbers include some of the biopesticides, some of the natural toxins, some of the very ancient known methods, like in ancient conditions people were using sodium chloride, like common that is common salt, to control the mites and other insects in the storage of the crop material. We were also using some of the organochlorine pesticides to control the insects and other pathogens in the environment. Most of the times we were using this pesticide even in hospitals. Say for example DDT, it was in use quite long back, may not be very long back, maybe in 5 or 6 years back we were using this DDT group of pesticides and its analogues in our in and around of hospital premises to protect the area from the insects and other pathogens contamination. So these pesticides were used to control the insect and pests, but at the same time they started giving the hazardous effect to the ecosystem. As I said, there are certain ways of contamination. Say for example, injudicious use of chemicals on crop. This injudicious use means the selection of a particular pesticide is not proper. There is a requirement of a particular crop for a particular pesticide. We need to select a particular pesticide to apply on a particular crop in a particular geographical area and in a particular season. Why I am saying in a geographical area or a season? Every geographical area is having a different problem of insects and pests or pest related diseases. So if a particular pesticide is not applicable on those type of insects or pest, then it is useless to apply all these pesticides, except we are adding to the contaminants part of the environment. So, and of course, in a particular geographical area, different season is having different population of insects and diseases, pest related diseases. So, season wise also we need to select a particular pesticide to be applied on a crop or any other industrial use. There are some social use of pesticides also common in India or in any part of this country. Say for example, we are using the liquid mosquito killer. Some brands are available in the market. That is also that is nothing but is a pyrethroid groups of pesticides. So that is not a harmful pesticides if we are using in a particular manner as described in the product manufactured by the product manufacturer. So I have given the examples of mosquito killer. It is used in a very judicious manner, so it is not giving any harmful effect to the society or to the environments. Some of the animal feeds, it can be directly treated or stored in a treated place, can contaminate the for the pesticide in the human population. Directly treated means there are some pesticides need to be treated on the animal body to keep them away from the insects or any insects related problem. Or as I said earlier that most of the time we are applying these pesticides on the crop, and the pesticides remains on the most of the times with the crop residues, and animals are eating those residues in the form of feed. So these pesticides get stored in the body and released slowly one by one, slowly time to time, because these pesticides are lipophilic in nature. They can deposited in the fat part of the body, and from there it can be released slowly. There are as I said, there are some social use of and industrial use of environments, these pesticides, and that can be contaminate the environments. There are some direct application of pesticides, as I said earlier, direct application on animal body or any crop, that if it is not used in a proper manner, it can cause the problem to the society. Misuse of spray material or equipments, this is mainly accidental cases. If there are some material or equipment used to spray or apply the pesticides on a particular crop or in a particular area, that same equipment or material is used for other reason, and then it can contaminate, this pesticide can contaminate to the atmosphere. And then splash of contaminated soil. As I said in the beginning, that some of the pesticides, mostly the organochlorine group of pesticide, can persist in the atmosphere for a longer duration, maybe for 100 years or maybe 50 years. So if the same soil is contaminated with a particular pesticide, that can be source of contamination to the environment. And if these pesticides are there in the soil, then the volatilization with penetration through leaf cuticles can also takes place, and it can create a problem of pesticide residue in food chain. This is a basic diagram of metabolism of pesticides, and either in animal body or human body. Pesticides gets entered to the body either through skin or through food or feed, and it goes to the gastrointestinal tract. From there it gets absorbed and stored in a liver. From liver it is slowly metabolized. It is not necessary whatever pesticide is going to the GIT it will get absorbed. Whatever is getting absorbed in the body, it will go to the liver. There slowly it will be metabolized and it will go to the circulatory system, either in plasma and or it will go to the fat cells. If it is stored in the fat cells, here it will only slowly mobilize to the circulatory system or excretory system. It can come to the milk or as a other milk animal related products like meat or eggs. These are some chronic examples of chronic exposure of low dose of pesticides. I am not talking about the very high dose of pesticides or accidental dose of pesticides. This is a low dose of pesticides, low and continuous dose of pesticides. It can create blood dyscrasis, allergy sensitivity, psychiatric sequel, psychiatric related problem, neurologic alterations. It can create a problem of hypertension, cardiovascular and liver diseases. Slowly, as we are progressing towards the dependence on agricultural products, at the same time there are cases of hypertension is increasing. There are the cases of diseases related to liver or cardiovascular system is increasing. We don't know whether this is the problem. This problem may be associated with the residuals of pesticide in the food chain. There are cases of reduced fertility of the in some part of the country. There are the cases of meiosis and insomnia. These are related to the low dose of pesticides in food chain. Pesticide residues, ppm, means milligram per kg in human adipose tissue. I have taken some examples of pesticide residues found in human adipose tissue from some parts of this world. Like in the case of United Kingdom, the DDT, I have taken the examples of two pesticides only, DDT and BSC, because the database is available for two pesticides as good as any other pesticides. So I have taken the example of DDT and BSC, and this DDT means all 6 isomers of DDT and all 4 isomers of BSC. In UK, the DDT level is 3.16 to 6 milligram per kg of adipose tissue. Adipose tissue means as a fat tissue. BSC is in the range of 0.015 to 0.35 milligram per kg. France, the data is available only for DDT, that is 5.2 milligram per kg. The BSC data for BSC is not available in France. Holland is using both the pesticides, and the range is 2 to 10 milligram per kg, and BSC is 0.1 milligram per kg. In Italy, the DDT is 8.2 milligram per kg in adipose tissue, and BSC is 0.06 milligram per kg in adipose tissue. In the case of USA, the DDT contamination level of human adipose tissue is 4.9 to 10.3 milligram per kg, and in the case of BSC it is 0.06 to 0.48 milligram per kg. In India, we are also not far behind of this country. In our case also, the DDT contamination level ranges from 11.9 to 27.8 milligram per kg of adipose tissue, and the BSC is 0.9 to 1.7 milligram per kg of human adipose tissue. New Zealand and Australia, they are not using BSC, they are using only DDT in their agriculture crops. So the contamination level of DDT in New Zealand is 5.3 milligram per kg of human adipose tissue, and in Australia the DDT level is 1.7 milligram per kg of human adipose tissue. So from this data we can conclude that all over the world the use of BSC is somehow restricted, and its persistence in the ecosystem is decreasing with the year passing through, and the DDT use is as good as in any country, and we should restrict this to that level, so that we should not contaminate our environment with DDT. The use of DDT should be banned practically and effectively. From this data we can say that India is using DDT more as compared to any other country. This data is on higher side because in Indian perspective is higher side because in our country there are part where we are using DDT or any other pesticides more than any other part of the country. Because of that reason the exposure level is higher, because we have the data always taken on an average basis. But let me assure you that some parts of the country they are not using at all the pesticides, but there are some parts where we use pesticides injuriously. We need to take care, we need to educate the people so that they should not use the pesticides in judicious manner, or they should not use the pesticide when it is not required. There are cases where people are using pesticide even if it is not required. So we need to educate the people in a right manner, in a right time. Now come to the steps of residue analysis. Here I will discuss one each point. The following steps are there, like sampling, extraction of residues from sample, removal of interfering co-extractives, dilution or concentration, identification and estimation, and if identified then confirmation of the presence. Let me start with sampling. Sampling is very important because whenever we are doing any pesticide residue analysis, we are doing at a very lower level, maybe in milligram per kg, or most of the times in microgram per kg. So working at a microgram per kg level is not very easy. Any improper sampling may end up with the improper or insufficient results. So sampling is very important. To have a very good sampling, we need to have a large volume of samples, mix the sample properly, and draw this laboratory sample, a representative laboratory sample, so that you will get a very uniform database, uniform results from a particular sample. Now come to the sample. What kind of food sample is required to be analyzed for residual pesticides? Let me tell you, all the food samples or any water or beverages are contaminated with pesticides in some way or other way. The contamination is not so alarming, but there are some residues of pesticides found in products like drinking water or any other packaged drinking water, natural mineral, except the natural mineral water. In case of honey, and milk and milk products, rice, wheat flour, and there are some other very common food products found to be contaminated with a trace level of pesticides. This trace level of pesticide most of the times below the recommended level of pesticides, daily dose of recommended level of pesticides. So nothing to be alarmed, but we need to take care and we need to be very alert. Now come to the sampling part again. If it is water sample, we need to have at a minimum of 1 liter of water. In case if it is some other food sample, like sample containing less fat, we need to have at least 50 gram of sample. And if it is a sample containing good amount of fat, then the sample amount can be 10 gram or 25 gram depending upon the fat percentage of the sample. Then come to the extraction of residue from the sample. We need to extract the residue from the residue means pesticide residue from the sample using either ether or dichloromethane. For example, if it is water sample, we need to add 250 ml of dichloromethane and 200 ml of ether. Maybe it may be a petroleum ether. Extract the sample vigorously, then separate the layer of ether, then repeat the extraction procedure again with the help of ether, and combine the ether part, dry the ether under the vacuum nitrogen condition using turbo vap or vacuum rotary evaporator. Then reconstitute the dry sample to 1 ml or 2 ml using either hexane or methanol. Then inject this sample to the GC system or HPLC system. I will come to the instrumentation part in the subsequent slide. I have given the example of water sample preparation. Now if it is food sample, then the basic idea is to extract the fat from the sample first. After extraction the fat, we will have to extract the residual pesticide from the fat using ether, and then same you need to dry this ether part of the sample and then reconstitute using hexane or methanol. Here I need to alert you, if you are using hexane or methanol for the reconstitution of the sample, you need to reconstitute or dilute the standards, reference standard in a same solvent. Maybe if you are using hexane for this sample, you need to use hexane for standard. Then come to the removal of interfering co-extractives. This is required in the case of food sample, not in the case of water. If it is drinking water or packaged drinking water, then removal of interfering co-extractives may not be required. Interfering co-extractives means whatever extractives comes into the ether part, it may not be pesticide, it can be some other interfering material, analytes, other than analytes. So for that reason we need to pass the extracts of ether to from the silica column. Silica is it is the fluorosil of 60 to 100 mesh housed in a glass column, and above the silica there we need to use some small quantity of sodium hydroxide anhydrous to restrict the water if there is any in an ether part. Then remove the interfering co-extractives and then make it a final volume using the hexane. Or dilution not take place in the case of residual analysis. Most of the time we are concentrating the final volume. Like in the case of water, we have taken 1 liter of water and finally concentrated to 1 ml. So this is one part we need to take care. We need to concentrate to a volume, either maybe 1 ml or 2 ml, but this 1 ml or 2 ml volume should be correct. Then we need to inject the sample to the instrumentation, either GC or GCMS or SPLC, and where we need to identify the particular pesticides using the reference standard. Reference standard will come at a particular retention time of the analysis, and at the same time if there is any peak coming out in the sample, so identification is there based on the reference standard. Then we need to estimate using the peak area of the standard and peak area of the sample, then standard concentration, sample weight, and following all the dilution factors. And if there is any identification taken place, if there is any pesticide found in the sample, we can confirm the same pesticides whether it is really present in the sample or it is giving a false result using a MS technology. Now come to the instrumentation part. I have segregated instrumentation from the sample preparation so that one can understand easily. GC with ECD. GC means gas chromatography with electron capture detector. This is used to analyze the organochlorine pesticide, organochlorine group of pesticides or organosulfur group of pesticides like DDT, BSC and some other organochlorine pesticides. GCFPD is used to, this is flame photometric detector, this is used to analyze the organophosphorus group of pesticides like malathion and other group of pesticides. GCNPD is also used for the organophosphorus group of pesticides, but GCFPD is much better than GCNPD. So nowadays the GCFPD is most preferable detector of gas chromatograph used for the organophosphorus pesticide analysis. Then there is GCMS, gas chromatograph with MS detector. This is also a very good instrumentation required for the analysis of residual pesticide in food products. Here we confirm the presence of pesticide based on the mass of a particular analytes. Then there is a LC-MS technology that is also can be used for the residual pesticide analysis, and there is HPLC. But let me tell you, the HPLC is dedicatedly required for some acid herbicides like 2,4-D and isoproteron. We need to analyze these two pesticides only using the HPLC or LC-MS technology. We cannot use these other techniques like GC, ECD, FPD or MS for the analysis of 2,4-D and isoproteron. Other than the organochlorine, organophosphorus, there are groups of pyrethroids, there are groups of organosulfur group of pesticides. This can be analyzed using GC, ECD, or the same can be analyzed using GC-MS technology. But for the carbamates group of pesticides, we need to have the HPLC or LC-MS. We cannot use this GC technology, gas chromatograph technology, for the analysis of carbamates group. Other than acid herbicides, the carbamates group also can be analyzed on LC-MS or HPLC techniques. In most of the cases, we are using GC ECD techniques, GC FPD techniques and GC MS techniques along with LC MS techniques for the analysis of residual pesticides at a very trace level. Say for example, in the case of GC ECD, we can achieve a target of 0.01 or in some cases 0.05 ppb level. ppb means it's a microgram per kg level or microgram per liter level. In case of FPD, we can achieve a target of 0.05 ppb level, and in case of GCMS, here also we can achieve a target of 0.05 ppb level in case of most of the food samples including water and beverages. LC-MS technology is better in terms of reproducibility and repeatability of the results, but in nutshell, GC ECD and GC FPD is much better in terms of routine analysis. Here we can identify the particular analytes or particular pesticides using reference standard. This is based on the retention time of particular pesticide in a reference standard, and at the same time, if there is any peak coming in the sample, we can take that peak or pesticide as a positive in the sample. But at the same time, I must tell you, the same peak in the sample may not be the peak of a reference, same peak in the reference standard. It can be any other analytes of most similar chemical characteristics. So it can come at the same or nearby retention time. To clear all this doubt, we need to have the MS technology in place, like GC-MS. Nowadays, the GC double MS means GC triple quadrupole technology is available in the market. So most of the laboratory is going for a GC-MS technology, where we can analyze the mass in a perfect manner. The analytes can be detected based on a particular mass and their daughter mass. In some case, food samples, we need to have analyzed somewhere 95 or more than 95 analytes in a pesticide in one sample. For that reason also, we can combine LC-MS for most of the pesticides to be analyzed in one run, in one analysis, or rest of the pesticide we can analyze using the GC-MS techniques. Here the identification and confirmation is much better than any other techniques. There are some methods that describe the spectrophotometer techniques for the analysis of pesticides, but at present scenario, these methods are outdated. We cannot use this spectrophotometer techniques for the analysis of residual pesticides. If there is any methods describing the spectrophotometer, you can just avoid. You cannot use for the residual pesticide analysis. You can use the formulation of pesticide analysis. As I said, all these methods are available. I have given a brief methodology as well, and all these methods are available in a different documentation source like Indian standards. Some of the Indian standards, they describe the analysis of pesticides, like Indian standards is available for 2,4-D, for isoproteron analysis. But in case of Indian standards, most of the methods are for single compound analysis. There is no any method available which can analyze all the required means this is a product wise, like if it is a water sample, we need to analyze 30 pesticide in water sample, whether it is drinking water or packaged drinking water. So there should be a method which gives the methodology for analysis of 30 pesticide in single product in single run. The same techniques is available with some other documentation source like AOAC, American Official Analytical Chemist. There is a method like 970. This is one example I am giving you, 970.52. These are the methods where you can have the methodology for group of pesticide analysis based on the product nature. There are US EPA method, and there is a pesticide analytical manual which gives the methodology for residual pesticide analysis in most of the food and water sample. Even in the case of Indian standards, even our Indian standards mention the AOAC methods or US EPA method for the analysis of residual pesticide in foods and water. So to conclude this session, as I said, today there is no evidence of harm to the residues of pesticide to the human beings. If not exposed above the permissible limit, is comforting. But no evidence of harm is not the same as evidence of no harm. Some people change their ways when they see the light, others when they feel the heat. I am quoting this sentence because we need to organize the methods. We need to organize the sampling procedure of different food products and water products so that we can get the best quality of results. We should have the methodology in place so that one method can be used for one particular products. Of course, the method should be based on the nature of the matrix. Like if it is water sample, we should have our own method in place so that the analyst in the laboratory should not be confused to follow which method and not to follow which method. So these things should be considered, and this is not the part of course you students. This is I am just quoting you so that you should have the idea what is the condition in Indian scenario. So I think I have completed this session. Now to Dr. Saloja.
Thank you, Dr. Imran, covering the very complex topic in a very simple manner, covering all the aspects. Thank you very much.